Hello, in this video I'm going to look at deriving the double angle identities of sine and cosine starting from the sum and difference identities. So if you know these identities, and like I said I usually memorize this consolidated form, then you can derive the double angle identities. Now the double angle identities, let's go ahead and start with the sine. So what you'll have is you're starting out with sine. What you want to get is the formula or the identity for sine of 2x. So what you're going to do is take advantage of the fact that 2x is the same thing as x plus x, right? And now what I've done is got this in a form, which is a lot of what all this is, a form that I can use. So now I've got it in this form. It's just that this y is the angle x. It's just the angle x again. It doesn't matter. So I'm going to use this formula, except that where you see a y, you're going to have an x. So now I'm going to say, well, this is equivalent to sine x cosine x plus cosine x sine x, right? And so now what I can see is these are really the same. It's just that they're multiplied. You can use the commutative rule. So I'm going to say, instead of writing cosine x sine x, I'm going to write sine x cosine x. And here, I'll leave this alone. So now, how many of these things did you have that are called, that look exactly the same? Sine x cosine x. I have two of them, one here and one here. So I have 2 sine x cosine x. So here's one of your double angle formulas. Sine of 2x equals 2 sine x cosine x. There's one. Okay. Now let's go ahead and do the double angle formulas for cosine. Now imagine, since you saw the little trick of how to express the double angle as just the sum of two single angles that are the same, that's what we're going to do for cosine. So for cosine, if I start out with cosine of 2x, which is the double of an angle, right, and we're working with a double angle identity, then what I want to do is go ahead and be able to use this and say, well, I can split it up and say, well, that's x plus x. Right? And so now I'm going to use this formula. So I'm going to say, well, that's the cosine of x again, right? Because y gets substituted with this x. Minus now sine x again. Because you replace y with x. So now we get to work with this, and what I can see is this is cosine x times cosine x, which is cosine squared x, minus, now here, sine squared x. So this is already one form of the double angle formula for cosine. Cosine squared x minus sine squared x. Excuse me. So there's another one. And to get the other two forms, excuse me, for the double angle of cosine, we basically keep working with this. So we have cosine 2x equals cosine squared x minus sine squared x. I think I have something in my throat. Excuse me. But now, if you recall, cosine squared is the same thing as 1 minus sine squared. So I'm basically replacing cosine squared with 1 minus sine squared. And I still have this minus sine squared x. So now, if I combine like terms, I get 1 minus 2 sine squared x. So that's another form of the cosine of 2x. It's 1 minus 2 sine squared x. And finally, the last form we're going to start again with this right here, cosine 2x equals cosine squared x minus sine squared x. But now, instead of replacing cosine squared x with 1 minus sine squared x, we're going to replace sine squared x with 1 minus cosine squared x. All right, so you minus all of this. So now we just distribute. Minus the minus is plus. So we have 2 cosine squared x minus 1. So that's your other form here. So often what you'll see then, if we consolidate all of that, hopefully I wasn't too fast on that. Let me show you that again. Okay, so now let's put it all together. We have sine of 2x equals 2 sine x cosine x. And we have cosine of 2x equals, we have all these different forms. We have cosine squared x minus sine squared x. We have 2 cosine squared x minus 1 and 1 minus 2 sine squared x. It's all of these 3. All right? Thanks so much for listening. And by the way, let me just make a comment. These are super important when you're solving equations. A lot of times you'll have this and you'll want to change to one of these forms. That occurs very often. That's how you use these a lot. Thanks so much for listening.